So now the next thing is endothermic reactions. And endothermic reaction here, the amount of energy required to break down the whole bond of the reactant is higher than the amount of energy required to form a new bond of the products, and thereby the heat is penetrated from the surrounding to the system. It's referred to as exothermic reaction. So because in this case the heat energy that is required, or the energy that is required to break down the old bond, is greater than that of the uh, energy for the formation of the new bond. So it means that you need external energy from the surrounding to the system so that it will now balance to help in the production of the new bond. So that is the endothermic reaction. Endothermic reaction. So then presentation. So you see in this case, the energy required to break down the whole bond of the reactant molecule is greater than the energy for the formation of the new bond of the product. So that is why the heat is actually transferring from the surrounding to the system so that to make the reactions possible. Okay, then the next thing, this is the also a graph representing endothermic reaction. So it's also very essential to know how to differentiate the graphical presentation of endothermic and exothermic reaction, and this is it. So a graph, we are now going to show a graph showing the two reactions. So look at it. This is for the exothermic reaction and this is for the endothermic reaction. So you see the differences here. This is the activation energy. This is the activation energy. So look at the activation energy in the endothermic reaction is far higher than the activation energy in that of the exothermic reaction. And look at it, the heat energy is released for the exothermic reaction and heat energy is absorbed. Okay. And this is it. Remember, I told you for the enthalpy change during an exothermic reaction, look at it, it is negative because the enthalpy of the product is less than the enthalpy of the reactant. So that is where we have this as negative, and the enthalpy of the product is greater than the enthalpy of the reactant in the case of endothermic reaction. So all these things are important. Then the next thing that we are going to look at is the different types of heat reactions. We have heat of formation, heat of decomposition, heat of combustion, enthalpy or heat change of neutralization. So the heat of formation of a compound might be defined as a quantity of heat change during the formation of one molecule of a substance from its constituent element. So remember, when we are talking about the formation, it means that we have 1, 2, or 3 elements that will now combine to produce or to form a new product. So the quality or the quantity of that heat that is required to form 1 mole of a substance from this constituent element is what we call heat of formation. That is the heat that is okay. So now look at it. What are the constituent element here? The constituent element here we have carbon and oxygen. So carbon and oxygen react to produce 1 molecule of carbon dioxide. So in this case, the quantity of heat that is required for the formation of carbon dioxide will be the enthalpy of the reaction under the conditions above. So you see, this is the enthalpy of formation and the value is minus 383.5 kilojoule per mole. So with this reaction, we'll understand that with this standard enthalpy of formation, since it is negative, this tells us that the reaction is exothermic reaction. And here all reactants are written in the standard state. So they are all written in standard state. S here stands for solid and G here stands for gas, and then G also here stands for oxygen. And 1 mole of product is formed. that is carbon dioxide, and this is true for all the enthalpies of formation. Then the heat of the decomposition, you see, is the amount of heat required to decompose. To decompose 1 mole of heat to its constituent element is called the heat of decomposition. So this one is like a reverse of that of the formation, because here you already have a single product, and this single product is now being breaking down. So there is a need for the input of energy. So heat is absorbed so that to break down the bond between hydrogen and oxygen to produce free oxygen and hydrogen. So that is why delta H here is positive. And then the heat of combustion. So in the heat of combustion, that is a heat of combustion of a compound or element is defined as the amount of heat evolved when 1 mole of substance is burned completely in oxygen as a given temperature at 180. So you see, in this case, we have methane decompose or break down to produce carbon dioxide. So for these carbon dioxides being broken down or to burn in the presence of oxygen, a heat is released. So the quantity of that heat released as a result of the combustion of methane in the presence of oxygen is negative. So that is why from here, because our delta H is negative, so this tells us that the heat of combustion is exothermic reaction. So ladies and gentlemen, I want to say something here very important. When we are talking about the this thing, thermodynamics or thermochemistry, so in each of these heat of reactions, we need to understand which one is exothermic and which one is endothermic reaction. And we can know that one based on the delta H value, that is the enthalpy change of the reaction formation or combustion, decomposition, and the rest. And also at the same time, we can know whether the reactions is exothermic or endothermic reaction based on the types of the reaction, because the first one is the heat of formation. So for something to produce new, so there must be an input of energy that will be used in the productions of the new bond for the formation of the product. So then the next one is the enthalpy or heat of neutralization. So the heat of neutralization is defined as a quantity of heat or enthalpy during the formation of 1 mole of water by neutralization reaction of a required amount of an acid or base. So you see, this is a reaction between acid and base to produce water molecule and sodium hydroxide. So the heat that is required to neutralize these reactions is what we call heat of neutralization, and delta H is negative. So this one is also exothermic reaction. Then the next thing that we are going to look at is his law. His law.